Good afternoon, everybody, and welcome to today's webinar, Energy Security, the True Cost of Energy. My name is John Clegg. I'm going to be moderating the event today. I've worked in the oil and gas industry for a little over 30 years. I'm currently consulting on some oil and gas drilling issues and also building a new company to develop drilling technology for geothermal energy. With me today, I have Steve Cromar. Steve will speak in a moment. Steve started his apprenticeship in the shipyards of the Clyde, studied mechanical engineering back in the 80s while working in Edinburgh, and then joined Vetco Offshore working on wellheads, production trees, well tieback systems. He worked for a number of operators offshore, drilling exploration wells west of Shetland, and then production wells in the central North Sea before moving to production engineering. Steve's taken early retirement and remains active in the SPE, Society of Petroleum Engineers, ISO, and of course the IMechE, and is working to develop new industry standards and industry collaboration. We have a panel that's going to be discussing the presentation after the event. I'll briefly introduce them now. Kevin Fitzgerald has over 30 years experience in high hazard industry, and until 2021 led Lloyd's Energy Register's UK and Spain risk management consulting team. He's now working as an independent consultant, with his professional focus being on helping organizations to improve their performance via culture and systems. Kevin is a fellow of the IMechE. Klistenis Dimitriadis is a drilling manager with more than 20 years of international experience, currently with Sasol and previously with Tullow Oil and with Shell. Steve Johnson is VP Digital for Petrofac's Engineering Production Services business. Steve has over 20 years experience in the oil and gas industry, working in a number of senior roles focused on ensuring operational readiness, optimization of performance, reliability, and integrity management. And finally, Pradig O'Hara is a mechanical engineer with 15 years experience in filtration and separation and process industries, including technology selection, process design of filter and coalescer systems, and their optimization and troubleshooting in service. So that's our panel. Our speaker is, of course, Steve, and without further ado, going to hand over to Steve and look forward to hearing your presentation.
So the true cost of energy is something that everyone's considering these days. It's cost of energy has gone up, so we're all having a look at it. But the environmental issues have not gone away. So we're having a look at these presentations. We try to examine the energy roadmap and provide you guidance on how to use energy wisely. Now, in this presentation, I'm not going to try to answer any questions, but I'm going to suggest questions which you should ask when looking at these issues, because they're all very special and very unique to each individual case. First thing I like to try to impress upon you is because the oil and gas has a high energy density, very low price. We've actually been living in a very lucky time. The past 4 to 5 generations were lucky to live in this time when cheap energy allowed a massive rise in social and technological advances. That time is now over. Things have now changed. Let me push this example forward. I'm giving you an example here with petrol at £2 a litre. That's when I first made this presentation, but let's just use that number just now. And you can see the breakdown of what makes up the price of a litre of petrol. So 40% of it is fuel duty. VAT, the retailer's profits, and then biofuel content. 27% of the actual cost is the cost of the petrol. So if you take your £2 a litre, which I know is very expensive, the actual cost is only about 54p. Now, if you take a litre of Avian water, which is 89p with 20% VAT, the actual cost of the water is 71 pence. So even at £2 a litre, petrol is cheaper than water. So let me impress that on you one more time. How much energy do we actually get from a litre of petrol? Well, it contains 30 to 32 megajoules, but what does that actually mean? Well, a modern car weighs about 1.5 tonnes, 32-ish miles to the gallon. So to move a car 1 kilometre takes 0.089 litres of fuel, which costs about 8.4 pence. So it's 1.5 tonnes of car is going along the road for 4.8p. Now to try to get that, imagine trying to push the car yourself 1 kilometre. How many bottles of Avian you would need? You'd understand how much energy we actually get for such a low cost. So we're talking about the transition, oil and gas, but one thing that needs to be understood is that we're still increasing our use. These slides I'm showing you here is from the International Energy Outlook. If you looking at any of my slides, you'll see that there's a note at the bottom right hand side, and that's where I get my information. If you want to look up any of this information, the reference is there. Go and check out this information for yourself. But this slide says that in 2050, 50% of our energy will still come from oil and gas. We're actually going to increase our energy needs, so it still comes from oil and gas. So let's think about energy in terms of finance and CO2. Now, I'm not sure if you can see this too well. It comes from the energy cost comparison. I've given you the slides there so you can go and look at it yourself. But what it is the fuel price per unit, and the unit is kilowatts or whatever there, and then looking at it at the boiler efficiency as well, and then the CO2 which is produced. And I'd like you to notice two things. First of all, gas is the cheapest fuel price per unit. And the second thing is, look at the column CO2, kilograms of CO2 per kilowatt hour. And you'll see it's all very similar when you actually look at it, including electricity. And that's at standard rate electricity. So you need to start thinking about, where does this electricity come from if it's still got such a high CO2 burden? So I'm going to give an example of electricity, and I'm giving you my example. This is my electricity. I've got this straight from my electricity bill. I'm buying E.ON renewable electricity, but the price has gone up. It's renewable electricity. How can this be? So when you go onto the E.ON website, there's the reference at the bottom right hand side, you see that the fuel mix, there's actually 11.8% natural gas, 0.09% coal. So my 100% renewable electricity is got gas in it. How can this be? Well, the way this happens is there's things called REGOs, and this is a certificate. So for every 1,000 units of renewable electricity generated, Ofgem gives the generator a certificate. It's a renewable REGO. It's can be separated from that renewable electricity. So you can sell it separately. So you sell your electricity, then you can sell your certificate. They cost about 15p each. So it's possible for suppliers to buy as many of those and then attach them to coal or gas. And that's how my renewable electricity is legally claimed to be 100% renewable because they've attached a REGO on it. Okay, well, that's fine. Let's not talk about the incentives there, but let's just think about the money. So we'll accept that 11.8% of my renewable electricity is from gas. So if the gas price goes up, it should go up by 11.8%. That's the proportion of my electricity which is gas, which is about 55%. But the gas price is tracking the electricity price, despite the fact that 85% of it comes from renewables. This still makes no sense to me. we need to dig further. So in the UK, there's one wholesale market for electricity, and those are negotiated every half hour between the suppliers. It fluctuates a little bit, but renewables supply about 40% of it. But it still goes up, and this is because of a thing called the merit order. Now, you need to pay attention at this bit. The electricity price in every half-hour period is set by the marginal cost of the last generating unit to be turned off to meet demand, which is a gas-powered plant. So that means that the gas price sets the marginal cost for all the electricity which is sold. Now, I'll read that again. You need to, I still don't understand it. Anyway, the electricity price is set every half hour by the marginal cost of the last generating unit to be turned off to meet demand. So when you turn off a gas-powered plant, that allows you to charge the gas price for your wind, your nuclear, anything that's and give it a high marginal cost. Now, there's the website I got this from, Good Energy down here. It gives you an analogy to try and think about it, make you think about this. So the analogy is a penalty shootout in a sporting competition. A team sets the individuals, but it's the individual who steps up to the last who has the final say. He decides the final fate of the result. I still don't quite understand that, but okay, we'll move forward. So let's assume the last player in that shootout is Ronaldo. So that means we can charge the ticket price based on his cost for the whole team of 11, plus the substitutes, plus the cleaners, plus the greenkeepers. So we could charge the ticket price based on Ronaldo's cost. That doesn't sound right to me. Anyway, let's have another quick look at the breakdown of your fuel bill. So we have the wholesale price, which we've just discussed. Then you've got some green levies, which pay subsidies to the renewable energy generators. So not only are they getting a large margin because it's setting the gas price, they're also getting a renewable levy handed out to them as well. And then, of course, we pay VAT on top of that, and that helps pay for the latest energy price guarantees, of course. It all balances out in the end. So what's this running costs here at the bottom, right? Let's have a look. We also pay a standing charge for the connection to the grid. And you'll notice the chart at the bottom here gives us the current rate and the energy price guarantee, which are the ones that are coming in the 1st of October. So I've used those numbers. So basically, to be connected to the grid, we're all paying £103 per year for the gas and £169 a year for being connected to the cables. But they're the same cables and the same generating stations and the same wind turbines, but the price has gone up for some reason which I don't fully understand. So this is something that the government's looking at. I know that Liz Truss is certainly looking at that, but we will stay out of the politics. So because of the setup of this, all renewable electricity has an excellent turn on capital invested. They've always chosen first, which is good, so we get lots of low energy CO2 reductions, and it's good for reducing emissions. But we do pay a high. But if you actually look at what is used, energy generated by fuel type, you can see that percentage-wise, it's still most of it's gas, wood, nuclear, and wind. Solar as well is in there. So all this money must go somewhere. If you want to know where the money goes, look in the Financial Times. So this is a clip from the Financial Times. UK gas and electricity distributions have higher profit margins than any other sector. The regional infrastructure, whose pylons and cables carry electricity, are making margins of 42.5%, and gas distributors are making 40%. So that's where the money's going. Very high operating margins for those. Yet we're going to have a windfall tax on the oil and gas companies, and we don't seem to understand where this is. Anyway, we'll stay away from politics. So we have got a British energy strategy that came out in April, and each of the sectors is looked at here in detail. So we have oil and gas. So oil and gas has certainly been trying to be bumped up. There's a new licensing round coming out, and there's talk of starting up fracking as well. But oil and gas can be used for many things, but it will still be part of our energy mix right up till 2050. It's going to be 50% of it, but the British Energy Strategy says it should be net zero compatible. So we're still going to have 50% of it, but it needs to be net zero. So that's probably the biggest challenge there of what we need to do. Hydrogen, there was actually a hydrogen thing in the strategy, but remember, hydrogen is not a fuel source as such, it is a fuel storage mechanism. So you have to make hydrogen. And there's an ambition to double it to 10 gigawatt production, and also up to about, that's by 2030. And in 2050, we're talking about 240 to 500 terawatts of low carbon hydrogen supply. Low carbon hydrogen supply, remember, being something from a green source or something where we have carbon capture. Notice carbon capture is in there in the third bullet point on the key measures. So Europe has a plan to deliver 50% of Europe's energy from hydrogen. And you can produce it directly from wind farms. There's one in south of Glasgow, they're talking about creating that. But it is a principal method of storing energy. It's inefficient, you lose a lot of energy doing it. And one thing you do need is a lot of clean water. The amount of water you need to produce hydrogen is quite high. But the CCUS is not directly mandated, but it is included in there, so it's part of the strategy. Now come to wind. Obviously, big high margins, everyone's jumping in. There's a big bonanza at the moment on the west coast of Scotland. Massive infrastructure being put in there. Everyone's jumping onto wind, and I think, to be honest, it's a great opportunity. It's great, but the only problem with wind is people don't want it in their budget. So planning permission is the biggest hurdle for fast onshore development. Therefore, we create more offshore and floating wind, which is slightly out of people's view, therefore out of sight, out of mind. And you can actually produce wind, produce your wind production with hydrogen and produce that hydrogen offshore and then ship that to where you want it to be. Now, nuclear, there was a big push for nuclear increase, but lots of people have said, well, this takes a long time to produce. And they're talking about up to 24 gigawatt in 2050. So that's 25% of total demand, which is a massive increase. And the thing is, we're actually working on a major one at Hinkley Point at the moment, but do we have the people, do we have the means, do we have the ability to provide that? We need up to 8 new reactors across the next, by 2030. So how long will it take to get approvals? Very difficult to get approval for wind farms, let alone a nuclear power plant. And have we got the skills? But you must know that the cost of the construction is added to our bills just now, even though we're not getting it. And with nuclear, you need storage. Remember when the Hunterston power station was built in the 50s, they also built the water storage system in Mount Cruachan in Scotland to try to take that energy when it was off-peak. So possibly small nuclear reactors would be a small method there that may be required. Solar. Now, solar has a great potential, certainly in the south of Scotland, even in the north of Scotland, and you can get enough energy from the sun to be viable. It used to be that it took about 25 years to pay it back, but I think now the calculation comes about 9 years, even in Aberdeen where I live. So it's potential. The other thing is most of the solar panels actually now come from China, and everybody wants them, so prices are going up, supply and demand, and getting them over from China, the shipping problems, etc. So, but it is a low cost, near constant zero CO2 electricity solution, so definitely solar has got to be part of the mix. So we need to get planning permission. There's talk about why should we put in solar farms when we need those farms for food crops, especially with the latest issues with foods production globally. But home systems are probably the best way to do this. Sticking some solar panels on your home and generating more electricity than you need is a much more attractive way to do solar. But you need some kind of solar energy storage again. So this question of storage keeps coming up. So how are we going to do that? Hydrogen, charge it into car batteries, leave them on the road, etc. But car batteries can be charged in factories, and then you fit the whole charged battery in the car. I've seen that on proposed over in Sweden. They're doing that. So you just change out the battery rather than sit and charge the car. But there is a world shortage of lithium. That needs to be addressed. And I've noticed that some lithium is coming out of some of the geothermal wells down in the south of England, so that's another potential there. Talking of geothermal, these were not mentioned in the energy strategy. Something that really should be is geothermal. Geothermal is an excellent source of energy and can produce, as I said, byproducts like lithium, etc. Waste to energy, there's one here in Aberdeen. Anaerobic digesters, direct air capture of CO2, so sucking CO2 out of the air is a viable way of doing things. Energy inefficient, but when you've got lots of energy that you're not using off-peak, that may be a thing that you want to do. And of course, sand batteries. A lot of talk about sand batteries as storing heat energy. So, how long is it going to take us to get this lot done? Onshore wind, we can construct, these are construction times, we can construct in 1 to 2 years, the same with offshore. Same with solar, if you can get hold of your panels. Hydrogen takes a wee bit longer. Oil and gas takes 5 to 7 years, and nuclear, well, I've said 5 to 7, but it could be closer to 10 in some cases. So, you know, if we're looking at quick solutions, wind and solar are probably the best ways to go about it, if we can provide the planning permission to get those onshore, obviously cheaper, and offshore if we have to get those applied. So, questions you should ask. When they say energy security and the true cost of energy, what do you mean, financial or environmental costs? And we do have to take those both into account, because even with oil and gas, it's got to be carbon neutral by 2050. So that has to be taken into consideration in all future plans. Do we know the form and source of the energy, and do we know the energy pathway? Every time we change an energy form, we lose efficiency. You know, you take electricity, turn it into hydrogen, lose hydrogen there, then put it through a pipeline, lose some energy efficiency there, then put it into your house, burn it, energy efficiency gone there. So all of that needs to be taken into account in the energy efficiency pathway. Legislation is going to make a big difference. Carbon credits and levies. We've had a small discussion about that. I still don't fully understand the logic behind that, but that's maybe just me. And then how much is lost in conversion and transmission, of course. But we need to start asking some deeper questions. How much energy do we need? How many people do we have in the country? How much is that per person? How does that compare to the rest of the world? There's an excellent site, ourworldindata.org. I don't expect you to see that, but it's worthwhile going on to that and having a look at it. And look at where our share of energy is per capita. It's quite interesting about who's using all that energy and where it's going. So follows quite a nice, interesting little curve there. So worthwhile going to have a look at that. Who's going to pay for all of this? That's one of the biggest questions, Maybe that's the way that we're going to reinvest all the cash that the transmission companies and electricity generators are doing it. Maybe that's how it's being done. Are they feasible? Realistic? Do we have the engineers? Do we have the manpower? Is the private sector expected to pay for it? Therefore, what's the incentive? I've shown there is an incentive there, but provided it's not just taken away as profits. And if the public's expected, what makes the taxpayers are willing to pay it? We're all going to have to pay for it one way or another. And finally, we come to a slide which some people don't like the look of. I don't like the look of myself. When you plot the world population against the global CO2 emissions, the one sits right on top of the other. So that basically says the more people we have on this planet, the more we pollute the planet, which makes complete sense. So if we try to only deal with the energy solution but still keep having more people, we are not going to achieve our aims. So we need to have a solution which has a global population solution in it. Now, Scotland, our population has actually risen and then remains very much the same and is very slightly dropping. United States of America, population has risen and is now slightly dropping. A lot of the other developed countries in the world have also risen and are now levelling off. So it could be that once you get a country developed and people start having a certain lifestyle, they no longer increase the population. So the solution to this may be that we get the rest of the world developed to the same level as we have, and then the population will level off. Now, I'm no expert in this, I'm an engineer, but I know that we do need to address this problem. And I think politicians in particular should stop panicking, thinking, oh my goodness, our population is dropping, and therefore who's going to pay the pensions and who's going to pay our taxes and all of those questions. Those things need to be considered and solutions come to without forcing or encouraging people to increase population. So we need a solution. Let us discuss. John, can you hear me?
I can hear you, Steve, yeah. Thank you for that presentation. I'd like to say a couple of points before we move on to the panel discussion. One of them is, there were some issues with sound quality. I think one or two people picked that up. Apologies for that. We'll figure out what happened there. I've been assured that the event is being recorded and somebody's going to be able to work their magic on the recording and make it much clearer to listen to. So you'll have a second chance to listen. I also would like to remind anybody in the audience that there is an Ask a Question box. There's been quite a few questions that come in, so thanks for those. We've got about 30 minutes to get through those questions with the panel, but feel free to continue to submit, and we will ask as many as we can. Steve, I'm going to start with one, kind of the elephant in the room over the last few weeks. You briefly mentioned fracking in the presentation. What do you think is the role of fracking and perhaps more accurately extraction of hydrocarbons from shale in the UK. What does the panel think has changed since the last time the institution looked at it was about 6 years ago? And is there experience from the industry that's developed quite a lot in the last 6 years overseas, particularly in North America, that we could import? Is it part of our energy mix, and will it contribute to our energy security? So, Steve, if you want to take that first, and then we'll open it up, the rest of the panel can contribute as well.
Yeah, that's fine. John, can you hear me properly? There's still a bit of background noise.
Yeah, I can hear you fine, Steve.
Okay, I'll talk up. Okay, so the question of fracking is quite interesting. A company I worked for was very successful at fracking over in the North American areas. They were very good. They managed to find a rock formation which would react to fracking very well. They managed to inject a whole bunch of water and fluids in there, prop the rock open, and it worked out really well. Then the same company went over to Poland, and we said, right, we're going to drill about 1,000 wells here, and we're going to frack half of the formation. And they tried a couple of test wells, and it just didn't work. And then they went to another place up in North America, and they had another bash at it, and it just didn't work. And they're starting to discover that only certain types of rock formations are actually going to work with this fracking. So we're still at the stage now where we're trying to find the rock formations which actually will work. We've only done a couple of wells in the UK, and we've not actually given it a good enough try to actually see if we're actually going to have a fracking industry here at all. So that must be the first thing we keep in the back of our mind. Fracking may not work in the rocks of the UK or anywhere near our region. It's very much along the lines of whatever the rocks are, what the geology is, all of that. Yes, so I know that they said they can go ahead and do fracking, and we're all going to get lots and lots of gas from that. So my answer to that question is, based on what I've just said, that's a very big assumption.
Thanks. So any of the other panelists want to pitch in on that?
Yeah, hello, can you hear me?
Yeah.
Chris Dennis here. Yeah, so I agree with Steve. I think this is a question that you cannot answer a priori. What I will say is that standards for everything, even for conventional oil and gas and extraction, are not the same everywhere. So we cannot assume, because, for instance, we see how it is done in Canada or in the US, that it's going to be done in the same way in the UK. So for this reason, I don't think that we can take the bad examples that we see, for instance, how it happened in the US, and extrapolate this to the UK, because this is not the same regulatory environment.
So your point there is about the talk of things like groundwater pollution and earthquakes. If these have happened in the US,
Correct.
You can't extrapolate that to the UK.
You cannot extrapolate, but as Steve said, you cannot assume that it will be all okay without doing the necessary engineering and investigations.
Yeah, which I don't think we've got that far yet in this country. So Steve Johnson, Patrick, Kevin, anything to add on fracking?
Pradig O'Hara here. I'm just going to add in there that I think it does deserve good consideration. Particularly at the moment, we are importing a lot of gas as LNG, and that is going to have a much higher carbon footprint than exploiting shale gas, assuming it's there. So if your goal is to reduce total emissions, then it has to be a priority over the increased carbon footprint of imported LNG.
Yeah, it'd be interesting to see what BGS had to say about it in their report when that's made public. Okay, any other comments from
so Steve,
yeah.
Steve Johnson here. Can you hear me?
Yeah.
I mean, I think, and staying away from politics, I think in my mind, the thing that needs to be considered here, which matches with what my colleagues on the panel said, is that it needs to be looked at in a balanced way based upon essentially the viability. If you look at it from a geological point of view, are the rock formations there that, from a technical standpoint, would mean that extraction of the hydrocarbons is viable, and can that be done in a safe, responsible manner, rather than a situation where we've had a moratorium that doesn't allow that optionality to be looked at. Because certainly, if we want energy security, and the points that were made in the presentation around the role that hydrocarbons will continue to have as we move towards net zero, then exploiting what's on our doorstep is a far better way of sourcing those hydrocarbons than bringing them in from overseas, be that essentially relying on unstable locations around the world, or bringing in LNG, which has got its own significant carbon footprint, as the prior panelists mentioned. So in my mind, I think the point made around the jury being out, as it being a viable option, is very true. But it's certainly worth something being considered rather than having a moratorium and taking it off the table.
Good, thanks. And that makes a lot of sense. So I'm going to ask a question, move on to a question that came in from the audience. And this is really about the conflict between energy security and energy cost. And the specific question was about whether subsidies of the price of electricity and the price cap should just cover the standing charge, or whether they should also cover the variable rate, the price per kilowatt hour. And I think that the point of the question is getting to the fact that if you remove the demand signal from pricing, so if the price of something is fixed regardless of how much you consume, does that have any negative impact, first of all, on security and the availability of supply, and also on other things that we would like to be working on, like reduction of emissions and encouraging people to use less? So who would like to take that first?
Pradig here. I'll take that. The energy price cap currently consists of two components for both electric and gas: a cap on the standing charge per day and a cap on the price per kilowatt hour. And that breakdown in cost is intended to reflect the actual costs of the consumer to the company. I'm not sure how they plan to implement the new price cap, but if you put the cap entirely on minimising the standing charge, then that would heavily penalise people who happen to unfortunately be high energy users because they have a large family or a high energy demand, and would disproportionately penalise them versus the actual cost of somebody who doesn't use much energy but still has that associated fixed cost in the provision of that energy.
Hi, it's Steve Johnson here.
Steve.
I guess one of the things I'd come back to, and it was in the presentation, is you've got the price cap on essentially the energy you use and the standing charge, but essentially if you look at the price to the user, the mechanism by which that price is being determined is actually not, inherently linked, to the source of the energy. So essentially, John was explaining, and even in the presentation says didn't fully understand how it works, but there is that linkage between the gas price, the wholesale gas price, and then that's charged across the board for the electricity we receive, regardless of whether most of your energy might be coming from a cheaper source at that point in time. So the cap is one thing, but I think there is a fundamental look that is needed, and I'm no expert on this, and it would need much brighter minds than myself to come up with the answer. But essentially, in my mind, there needs to be a greater linkage to essentially the source of the energy that is producing the electricity, and that being passed on directly to the end user, so that they can make choices, which may also, if we look at going towards net zero and a more renewable-based energy market may actually drive and help and aid that situation, as well as address some of the challenges on the price that we're receiving as users, and go back to that concern that John also pointed out about where are all the profits going. So for me, it's less about basically the pricing cap, which is coming in because of the impact of the prices we're seeing to the user, and more about the mechanism of how that price is determined.
Kevin Fitzgerald here. Just maybe to pick up on that point, I do believe that the government has announced within the last couple of weeks or so an intent to review pricing with precisely that in mind. That may have been overshadowed by other events that are underway.
That's good. Good to hear. That it would make sense, and you'd think it's possible to come up with a slightly more sophisticated pricing model than the one we've had over the last few years, which was pretty fit for purpose until the price of gas ballooned in the way it did. There's a related question. Sorry, go on.
Sorry, if anybody's interested in exploring that in more detail, I believe it was covered by the BBC a week or so ago. The government has specifically referred to renewable and nuclear generators there.
Yeah, which makes sense. And yeah, there's a related question that came in, really stating that common concept is return on capital should follow the amount of risk taken, and that distribution companies or utilities are not taking the same kind of risks as oil and gas companies or technology developers. So the question is, should the government impose utility level rates of return, 8-10%, on those distribution companies in order to contain prices to consumers? And I know we're going to stay away from politics, but does the panel think there's a place for that kind of intervention in the market? Steve Cromar, I'll let you take that first.
So yeah, I didn't answer too fast, but I don't fully understand the question. Could you go over it again?
Yeah, it's basically, should the government impose margins, maximum margins on the distribution companies in order to reduce the numbers that you had in your...
Yeah, okay. So some of these companies say that they're making this profit so that they can reinvest. But they're going to do that anyway, and they get incentives for reinvesting. So, that sort of goes out the windows. Other ones are just simply giving profits to shareholders. They're making a big windfall. So, yes, I think there should certainly be some kind of limit, maybe something like 10%, like other industries, 10% margin is a reasonable margin. Anything more than that, you either have to reinvest, particularly in low carbon energy technologies, or pay your windfall tax. That's basically what they've done with the oil and gas companies. You either reinvest it or you pay a tax on it. So that's a reasonable thing to do.
Anybody else want to comment on that?
I think that's a no.
That's a no. Yeah, I could pick victims that would go for a no. Okay, let's take. There was a question came in about geothermal, and it kind of piqued my interest because it's something I'm involved in personally. So I will answer it quickly, and that is about. Steve mentioned that geothermal energy is an excellent potential source of energy, but what's the potential in the UK? Because the questioner, Daniel, was under the impression we needed a more volcanic environment like Iceland. And it's very true. The way you see conventional geothermal installations is places like Iceland, New Zealand, Indonesia, and they're places where you're close to volcanic activity, you've got a lot of heat close to the surface, and you have fractured formations and a source of water, which is normally rain, that can get into those formations, become hot water in the fractures. You drill a well, and you produce hot water that basically becomes steam before it gets to the surface. You can use it to drive a steam turbine. There is a new generation of geothermal, unconventional geothermal wells, which are drilled in hot rocks without the water being present. and then the water or some other fluid, it could be CO2, is introduced in the process of operating the well. So, and if you want hot rocks, all you have to do is drill deep enough. The thermal gradient is different in different parts of the world, but there are parts of the UK where the thermal gradient would be suitable for unconventional geothermal wells. The problem in the UK is more regulatory because it's not at all clear who owns the heat and whether it's a property of the rock or whether it's a resource. So it's not clear whether the heat belongs to the landowner or to the government or the Crown. And it's that kind of issue I think would need to be resolved for the UK. I don't know if any of the panelists wants to comment on that before we move on, or we can get on to one of the other questions.
Yeah, John, could I ask you a question on that? Is geothermal a finite resource, or is it a renewable resource?
That's a good question. And I think for the purposes of the likely survival of the human population, you can consider it to be an infinite resource. There is a huge amount of radioactive decay of elements going on beneath the surface, which is providing effectively an inexhaustible supply of heat for the Earth. There are some practical limitations on what you can extract because of the thermal conductivity of rock. Thermal conductivity of rock is fairly poor, which is good news for all of us, because if it wasn't, we'd all be burning our feet every time we went out for a walk because of the temperature of the center of the Earth. But that heat continues to flow, and the heat flow is many times the global energy consumption of the population of the world. So you can effectively consider it to be renewable.
Excellent.
It'll probably last as long as the sun lasts.
Good. Any other comments? We'll take that as a no again.
Okay, so I've got a question from Sarah Long about the build rate that we need to hit our energy strategy numbers is between 12 and 17 gigawatts capability per year. The most we've ever built in the UK is 5 gigawatts per year. So how are we going to be able to do it, especially when we're going to be competing with every other country in the world for the engineers needed and the skills needed to create all of this generating capability? So
I can answer some of that. The IMechE Aberdeen area, we went up to Clegg in Scotland to see these the bases for the wind turbines being loaded out, and those bases are just the same design being produced again and again and again, stuck on a barge and stuck out there with a crane again and again and again, and then the same wind turbines were stuck on top, and it was just like a factory. And I think that's possibly the way we're going to have to do it. It's going to have to be a pattern. It's going to have to be a standardized design. It's going to have to be something that we can just, factoryize. Because so much of our power and generation, particularly nuclear, everything's brand new design, sucks up a lot of engineering power, an awful lot of time. So I think the only way that we can do it, to answer Sarah's original question, is we would have to do it on a standardized platform with standard designs, just sticking out one that doesn't quite fit there but will do the job just fine.
That's a challenge in itself, isn't it? Because I think the industries, the power industries and the related industries we've developed in this country, nuclear power stations tend not to be the same as each other. Shipbuilding tended to be bespoke, and our offshore structures tend to be bespoke. And there are countries in other parts of the world who are much better at mass producing things like large structures and offshore installations. So we're going to have to work very hard to compete with those guys in terms of being able to mass produce and build this capability, right?
Yeah, the bit I didn't tell you was the structures were coming from China. We were just loading them out there. So there you go.
I think that's part of the challenge. There is a related question, but anybody else on the panel want to comment on our ability to basically build the generating capability we need?
Steve Johnson here again. I agree with the comments you were making earlier there. I'd also say I see that there is an opportunity to, and one of the lost opportunities we've had in many occasions is building the local industry to support those. So I think there's an opportunity there to bring and a need to bring more people into the industry, not just from the point of view of the traditional sectors, from an engineering perspective, and also operations, where these facilities are offshore or onshore, whatever, but also, as was described there, in terms of the manufacturing side of things, we've got the opportunity to build capability, but that all takes time, and there's no doubt there's a challenge. But the other angle that I think was touched on in the conversation, the presentation, is the energy efficiency side of things as well. To achieve basically energy security, achieve net zero, I do think that there is a conversation to be had on the energy efficiency side of the equation, rather than actually presuming that we need an endlessly ever-increasing supply of energy to try and balance off, the growth in that demand, as opposed to, just looking at different sources and growing, the supply. We need to look at the demand side as well.
It's a very good point there, and that's actually a great plug for the next event in this series in December about how to use energy wisely. And I'm pretty sure that managing demand and looking at efficiency will both be themes that are explored in that event.
Yeah, I tend to agree with that. The efficiency, and there's the other side of the coin. Efficiency is the losses. There was a question I saw earlier, and it's about, is the housing stock ready for this new energy change? And the answer is no. We're not insulated. Insulation is the key to a lot of this energy problem. The amount of energy that's just simply wasted in the form of heat that goes through people's walls, that really is an issue. They keep on saying, get these ground source heat pumps, or get these air source heat pumps. I've been in a house with a ground source heat pump, and it works really nice. They were saying they have to open the windows at certain times, but that house was fully insulated. I was in another one with an air source heat pump, and it was terrible. There was no insulation in the house, and it just couldn't manage the system. So I think the answer is yes. We do need to deal with this insulation in houses problem and stop wasting energy. That's the answer to that thing.
Okay. Any other comments on that specific question about our generation capability and how we build it?
I guess just adding to previous speakers. Kevin Fitzgerald here. Just adding to what previous speakers have said, modular construction, I think, is going to be absolutely key to that, standardized design and modular construction. Yeah. And that is acknowledged within the strategy document itself. So it would seem there is some recognition of that. And I'd just like to pick up on the last point as well, and I absolutely endorse the requirement for economization around energy use as well. It is two sides of the same coin. And if we look at the amount of UK energy consumption that's consumed in domestic space heating, then it's clear that there's the opportunity to improve very significantly in a way which isn't really technically very challenging.
Thanks. Okay, I'll move on to, there's kind of a related question from Robin Hastings, and Robin points out that, I'm going to paraphrase what he said, but we're now paying the price for becoming dependent on distant sources of energy. And is there a concern? And there was actually, I don't know if anybody heard it, the Radio 4's Today program covered this earlier this morning, so it's very timely. Is there concern about security of supply with the raw materials that we need for developing some of our renewable energy? Things like rare earths, things like lithium for batteries and so on. And how can we as a country address that?
So Christian is here. I read an article incidentally yesterday about the possibility of having a kind of OPEC organization for rare earths. So it can happen, and I fully expect it's going to happen. That you're going to have some kind of let's say a consortium basically extraction of these materials, lithium, etc. So I think it's happening as we speak.
Yeah, that makes a lot of sense, and so it's a risk that we need to be aware of and to understand how to react to. Does anybody else on the panel want to comment on that?
Steve Johnson here. I mean, sorry, carry on.
No, go on, Steve. Steve Johnson.
No, I'll let you go. I've answered a few questions, so you fire away.
Okay. Pradig O'Hara here. Just as you say, there's perhaps a broader question globally around how globalized any country becomes and exposing itself to political changes in other countries, but it needs to be weighed up against the fact that the cost of many things in ultimate terms is a lot lower now than it was 60 or 70 years ago, and part of the reason for that is the economies of scale of effectively certain countries producing certain things, be that as a natural resource or as a manufactured product at vast scales. And it's a question that needs to be asked, and then is what's the price worth paying for goods in order to guarantee that a supply, and does that make the things that we need or want unaffordable to the general public?
Yeah, and that's a really good point, and I think that there has been a lot of benefit from globalization and from the economies of scale that you get, and I think there's maybe a middle ground where there's a role for maybe a little bit more attention to risk management and uncertainty management, and understanding what options would be if the future played out in different ways, if we become, or if we remain, as I'm sure we will, dependent on non-local sort of resources and raw materials. Okay, I think we've got time for one more question. We're getting close to our finish time, but I think we can run over by a minute or two. There's a couple of related questions about storage, and they're basically two sides of the same coin. One of the questions was about if the need for storage has a long lead, if storage has a longer lead time, like hydrogen has a longer lead time, does that mean that the lower lead times for solar and wind are limited because they require storage to go with them? And the flip side of that was a question about electric cars. Does that increase the consumption of electricity overnight? And I'm going to add a link between them, which is, to what extent could use of batteries, either in electric cars or domestic batteries, with of a similar nature but maybe slightly smaller scale, provide that sort of storage capability that we're going to need to be able to capitalize on the short lead times from wind and solar? That was a long question. I'll let Steve go first.
Well, thanks very much. So the question of storage, yes, batteries in electric cars, yep, you need your lithium and you do all that, but you're absolutely right. Wind turbines, I think we're going to be able to get those built, but then we probably won't be able to store them. But it's got to be useful storage. You can. I've actually seen some wind turbines recently actually being feathered back so that they're not actually generating any electricity because we don't need it. So you're not generating the electricity, so you're actually wasting an asset by not actually generating something there. So yeah, I don't think there's going to be a problem with it holding things back as long as you can bring it back onto the peak. But yes, you're wasting your asset by not generating the electricity if there's no need for it. So we do need to follow that storage back up again. But it could be a bottleneck if we're not careful. You're absolutely right. Building a hydroelectric plant which can store energy takes a long time. Batteries, obviously, we know that's got the lead time of the materials, and hydrogen. Well, they're doing some small hydrogen stuff here. Aberdeen's got a big hydrogen plant now, I don't know how long that's going to take, but they're certainly taking it into their heart here in Aberdeen. We've got hydrogen buses, hydrogen bin lorries. All the council vehicles now seem to be hydrogen, so that's not taking them too long to get that up and running. So that's an interesting point. But generally, anyone else got any other ideas on that?
Kevin Fitzgerald here.
Steve Johnson.
Do you want to go first, Steve?
Yeah, I mean, mine's quite brief. All I was going to say is that the comment that was made earlier around essentially the use of batteries within electric vehicles as part of the strategy the government published, I think it was earlier this year, the concept that the vehicle batteries will form part of a network of storage that can be utilized to manage the energy efficiently, and then in off-peak draw that back is actually discussed within that document. So it's definitely something that is part of the agenda. But we have the problem now that essentially power that is generated through renewable sources, we don't have sufficient storage to use that as effectively as we might. So it's definitely a problem that we've got to solve.
Okay, if I can jump in there, then I should stress I'm not an expert at all in this area, but I agree, share the observations that have been made by others. A couple of thoughts really. The first is that on the back of the increased take-up of photovoltaic cells, there's I think a healthy demand for indoor battery storage in addition to motor vehicles. And I do wonder to what degree that might be an opportunity. And the second thing is with regard to hydrogen storage, I believe that SSE and Equinor are developing a hydrogen storage facility on the East Coast, which I think they're indicating could be available in 2028 or thereabouts. That's it for me then.
Are you in there, John? Oh, it sounds as though John's disappeared.
Hey, yeah, sorry. I had a connection issue there. Yeah. Anybody else from the panel want to comment on that before we wrap up? I'll take that as a no.
Just a comment for myself. I was talking to a couple of guys that have got electric cars, and they were saying that in their contract there is actually a clause already in their contract that if necessary, the company that supplies them can actually draw back down on their battery. And of course, people started to react to that, saying, well, hold on a minute. I don't want to charge my battery up overnight, take it to work, plug it into the system, and then discover the battery's been drawn down and I can't get home. So, people will start being people and they'll start saying, right, I'll charge it up and I'm not plugging it back in when I get to work. I've got enough to get me home then. So, it's we all need to work together on these things, but I think we need to be also very careful that all these wonderful systems, when people become involved, that human factor just sometimes can muck it up.
Yeah, understood. Good point. So I'm going to apologise to people whose questions we didn't get to because there were many and we only had an hour. We've gone over our time. I'm going to thank Steve for a very informative and illuminating presentation and discussion. And as Steve said at the beginning, he was asking questions rather than giving answers. In the 35 minutes or so since the presentation finished, we've had time to explore the answers to one or two of those questions. And I'd like to thank the rest of the panel, Patrick, Steve Johnson, Chris Dennis and Kevin for their input, and thank the audience for yours and for your attention. And with that, we will terminate the event. So thanks everybody and have a great day.